Hello, fellow. My name is James Owusuapia, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
So in this question, it reads a C program contains the following variable declarations. Show the output resulting from each of the following printf statements. So now let us take very good note of the declarations. Now we come here and the printf function says print %f %f %f, and then here it's given us the values a, b, c. Now we realize that in our previous videos we talked about the percentage C and how that the percentage C had a default precision of 6 decimal places. 6 decimal places. It has a precision of 6 decimal places. So if you don't specify the decimal precision, it would just give you a default of 6 decimal places. So here we would look at A. Now A was initialized to be 7.5. So instead of 7.5, we would have 7.500000, which would be 6. So now let us count. It would have 7.5000000. So let us look at the precision now. 3, which is 6. Now for the second one too, which is B was initialized to 0.0765. Now the decimal precision here is 1, 2, 3, 4. Then we would add some 2 zeros, 5, 6 to make the whole decimal precision 6. So yeah, so the decimal precision would be that. And then for the other one too, C was initialized to 7,000. Now when we add a decimal precision, we would have to add 6 zeros since this one didn't have any decimal places. So we would add 6 zeros. So 1, 2, 3, 4, 5, 6. And then so our answer here would be this, because this one has 6 decimal places, 6 decimal places, 6 decimal places. So let's move on to our next question. Okay, so for this question, we already know that the number after the percentage sign stands for the minimum field width. And when I say this, I mean that if our total float has a maximum characters surpassing that of the minimum field width, then we leave it as it is. If it is less than the minimum field width, then the remaining spaces relative to the minimum field width is filled with spaces, just so it would measure up. So let's look at our variables. Now we know that A was initialized. We see that A was initialized to 7.5, but we've already discussed that a float has a default precision of 6, and since here they haven't given us any decimal precision, we would go with this default decimal precision, which means that our A would be 7.5000000. Now percentage B works with the same analogy. We know that percentage B was also initialized as 0. B was initialized as 0.0765. So in this question, since we need our default precision, we would add 2 zeros to make this measure up. So 0, 0. Now when we see this, we can easily tell that it satisfies what the percentage F stands for, because since the 5 there is standing for the minimum field width, we know that since the field width of the B exceeds 5, then it has exceeded the minimum, so we can keep it as it is. Now we know that C was also initialized as 7,000. Now if you look closely at the preamble, you realize that it was initialized as 7,000 with a point there, but they didn't continue. So here, since we are looking for our precision, since we initialized it as a float, then we would go on to add our precisional values. So C in its float point would be 7,000.60. So 1 2 3 4 5. You get the idea. So 1 2 3 4 5 6. The space is small, so but we get the idea that these zeros here would be 6, and that would account for our default precision. Okay, so let's move on to the next question. Okay, so for this part 2, so we know that percentage E stands for a scientific notation which is similar to a float, in that there are some matrices and you would be using exponents. Okay, so here let's have a feel of what this question means. Now when I say this 8, which is the number after the percentage sign, as I said in the previous question, is the minimum filled with value, the minimum. Okay, so we know that A was initialized as 7.5, and we know that the scientific notation is similar to float. Now here there hasn't been any precision, there wasn't any given precision here, which means that if I'm saying it's similar to float, then it means I can use my default precision here. Now exponentials, the scientific notation has matrices and exponents, but we don't have to go through that. We just have to know that we can relate it to floats. So when I give the initialization of A in the percentage E format, in the scientific notation format, I would have 7.500000, which will satisfy it, and then my exponent, because it's a scientific notation, exponent. But see here, we didn't move, it's already 7.5 already, so we didn't move to the front, we didn't move to the back, so plus 0 0 0. Now you have to notice that for the exponential value, for the exponential part here, always it has 3 digits, even if it is, let's say, so we have something, say a value point something exponent plus or minus 0 0 0 something here. We have, when we have, say, exponent this, when we have something like this, we have to know that the thing here, the values here has to be 3. Some would say in 3 bits, but that's also another topic on its own. So we have to know that the values here should be 3. They should not be 2, it shouldn't be 1, it should be 3, so that it can represent numbers on a large scale. Okay, so let's go to percentage F. Now B was initialized as 0.0765. so when we initialize, or when we place B inside our floating point here, we know that this one, we haven't been given any precisional decimal places, so we'll go with our default ones. So here we would add 2 zeros to make it add up to our default precision. So, and when we count it, we realize that it fits our minimum filled with description. So 1 2 3 4 5 6 7 8, it fits. Now when we go to percentage G, we have to realize something, that the percentage G is also used to print decimal floating point values, and it uses fixed precision. Now, what I mean by using fixed precision is the value after the decimal in the input should be exactly the same as the value in the output. The value after the decimal in the input, it should be exactly the same as the value in the output. Now we realize that C was initialized, we realize that it was initialized as 7,000. Now if you look very closely at the preamble, you realize that there's a dot after the last zero, which means that there is nothing there. So according to the definition of the C I just gave now, then if 7,000 is my input, then my output according to percentage G should also be 7,000. So I'll put the same thing there. So C should be equals to 7,000. Now one would ask, this doesn't fulfill our minimum width requirement. Yes, it doesn't, because the minimum width requirement is 8. This one is giving us just 4 characters, so the other characters would be filled with spaces. Let us move on to our next question. Now, as I also said in the previous one, the minimum filled width, we attain all of them. Okay, so now for this part of the question, for our first exponential value, we realize that all the exponents here have their, they have 3 whole numbers. So let's say like it's represented as such: e plus or minus 0, 0, 0. Now all of these can be replaced by any other number. So for the first one, which is A, we realize that A was initialized to be 7.5 with a precision of 1. Let us take note of it. It was initialized with a minimum filled width of 8 points, and a precision of 1. So what we would do here is we would actually write our value, which is 7.5. Now, had it not been that we need a precision of 1, we would have added the zeros and filled it to the maximum or the minimum width became 8. Because if we didn't have the precision, we would have filled it to the minimum width. We would have filled it till the minimum width became 8. But here we have a precision of 1, so we are being restricted to keep the decimal place to 1. So 7.5. Now to the exponent. Now we realize that here there is no exponent. We haven't done any exponential movement, so it's just plus 0, 0. Now one would ask, how does this fulfill the minimum width requirement? So let's count. 1, 2, for the dots, 3, 4, 5, 6, 7, 8. Because all of these are characters. They are all characters, so hence they fulfill our requirements. So let's come to the second one too. For the second one, we realize that B was initialized to 0.0765. Now, according to what we do as scientific notations, we realize that we move our decimal points, we would move it from the left to the right 3 spaces. So 1, 2, so 2 spaces, and we would get 7.65. And some of us would write 10 raised to the power negative something, but in C programming, it would, in the scientific notation that we are using to, it would be exponent negative 002, because we moved 2 decimal places. Now this would also satisfy our minimum requirement, because let us count. Now we wouldn't actually bring the 5 because we need a precision of 1, so this one is out since we need a precision of 1. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. Hence our requirement is fulfilled. Now let us go to C. Now C was also initialized to be 7,000. but we need an exponential. We are using an exponential notation, so we need something like a point, 7 point something or something. Yeah, so we would move 3 points to the left, say 1 2 3, and we would have 7.0, one decimal place, exponent positive 003. Since we moved 3 decimal spaces to the left, we moved 3 decimal spaces to the left, so our answer would be this. Our answer would be that. So let's move on to our next question. 8 and the G. So when we already know that this 8 stands for our percentage G. 8. 30 seconds, everything I try for me. Make a cut this for me. Just take note of the times you made a mistake then. I'm starting again, Seth, but I won't cut it. Okay. I'm starting from the 55th second. Okay, so in this question, we already know about minimum field width. We already know about the format specifier G. Now let us go ahead to talk about this new syntax that has been introduced, which is the 08G. Now we know what this does from the previous question, what this does. But what is this here for? Now we realize that for our minimum field width, we have to have a certain specific amount of characters that the format specifier must meet in order for it to be fulfilled. And if this minimum requirement has not been met, we know that the program automatically fills the remaining requirement with spaces so that it becomes eligible for display. Now what this 0 does is that instead of the spaces, it fills it with 0. So instead of this 0, I could place any other character here. It is a syntax. I could place any other character here. Maybe you would want to replace it with an asterisk. You can do percentage asterisk 8G and it would give you the asterisk padding. So now let us look at this question here. We realize that A was initialized to 7.5, B was initialized to 0.0765, and then C was initialized to 7,000. Now we know that the percentage G gives us the output of the value exactly how we inputted it. So let us go here. Now you realize that in this pattern, the spaces that would be left, they would not be behind our numbers, they should be before. Why am I saying this? Suppose we had the 0.5 and let's say we were doing a pattern, a 0 pattern, or let's say we were replacing our spaces with 0. If I had the 7.5 and maybe the spaces were at the back, maybe let's say the spaces are at the back here, and I actually wanted to pad it with 0. I actually wanted to fill the spaces with 0, and then I started filling these remaining spaces. Obviously, I would think that this is the float system. This is a float precision. Meanwhile, it is not so, and this could cause a confusion in the system or even among our viewers. So what the program actually does is every space is actually inserted in front. So let's say I have a 7.5 value here, but my minimum field width is 8, but here I have only 3 characters. Instead of the spaces, we would think that the spaces would be at the back, but no, the program actually inserts the spaces in front. So instead of you getting, maybe you thought it would be 7.5000, which is the space, or 7.5 space, it would actually be space 7.5 so that it would meet the minimum requirements for the percentage G. So here we realize that now let us not forget that this 0 is actually what would fill the spaces. The reason why for the previous questions we were filling it with spaces was that we left this place empty. We didn't actually cater for this part. But now we actually want to specify what should fill the remaining spaces. So we can specify it with this syntax. Now when we are done with this, let us look at the following variable initializations. So we realize that A was 7.5 and here 7.5 is just 3. 7.5 is just 3. So 7.5 would therefore be 0. It would be 0.5, which is this. We can just read this. It is this. And then for the other initialization too, we realized that this one was 1 2 3 4 5 6 characters. So we would need to add 2 for it to meet our minimum width requirement. Now if we look at this option 2, it has been added. The 2 zeros has been added to make it meet our minimum requirement. Now let us look at our 7,000. Now since if we had added the zeros to the back of the 7,000, it would have changed the whole meaning of C. Hence the reason why we also bring it in forward, so that we preserve their meanings, because we know that 001 if in decimal systems is just 1, and we know that 02, 03, 04, they are all the same, the 3, 2, 4s in the decimal system. So here we also do that to preserve the meaning of our variables that we get, or the meaning of what we have. So the padding system is just here to replace the spaces with whatever we want to fill that space. So that's it for this question.